Hello friends, welcome back to another chapter of my Godot series. I wasn't sure I'm going to continue this series, but after reading your amazing feedback and requests, I just couldn't resist. So in this chapter, I'm going to follow more key ideas that used in Celeste, and this time we're gonna cover the solids and more specifically platforms. And there are a few rules when it comes to solids. The first one is that actors and solids will not overlap unless in special cases, like jump through platforms, which we'll do maybe in the next video. The second rule is solids will not interact with each other, which is quite simple. The third rule is moving solids can push or carry an actor. And the last rule is push will always have priority over carrying. Okay, so let's add a new scene, and I'm gonna name it moving platform. It's going to be Node2D, and I'm gonna save it. Click Ctrl S, save it under the scenes folder, and I want to link a hitbox node. And let's use another color for this hitbox. I'm gonna pick light blue. I'm gonna put the width to 48 and the height I'm gonna set it to 10. Great, now we have a small little platform. Let's add the tween node to the root, and the final thing I'm gonna do is attach a script, and it's gonna be a moving platform. Save it under the scripts folder, click the open and create. As usual, delete all this stuff. And I want to add the reference to the tweens. I'm going to use onReadyVar tween equals $, tween. So I want to use this tween to move the platform from the starting position. So I'm going to add an onReadyVar start, and I'm going to set it to the global position, so where we put it in the level. And then we want to move it to an offset, so I'm going to use export_var offset, so we can set it in the inspector if you want. And for now I'm going to leave it at 0. Now another variable I need is the time, which is how much time it will take to get from the start to the offset. So for now it's going to be 2 seconds. And now from within the ready function, we're going to call the init tween function, and we're going to set up the tween. So let's write it, func init tween. Okay, so we can use this tween to interpolate the property, and I want to interpolate the global position. A tween can interpolate other stuff also, like method or callbacks, but we're just going to use the property here. The first argument it accepts is the object, so just self. Then we need to tell it the property name we want to interpolate. It's going to be a string of global position. Then the initial value is going to be start, and the end value is going to be start plus the offset. For the duration, let's use our time variable. And the next argument is the easing type or the transition type. And I'm just going to use quad here. Feel free to play with it if you want something else. Next, we need to tell the tween when to apply the easing. So I'm just going to pick easing out. And the last variable is a delay, so we can wait before we start to move the tween. So I'm going to add a new export var. I'm going to call it delay, set it to 1 second, and let's put this delay. Now I also want this platform to ping pong, to go back and forth. So I'm going to duplicate this tween. Instead moving from the start to the end, I'm going to do start plus offset, and the end value is going to be the start. And now in the second tween delay, we need to take an account for the first tween we did. So we need to add the time of the first tween plus its delay and our delay. So it's going to be time plus 2 times delay. I want this tween to repeat forever, so I'm going to set tween.repeat to true. And then we're going to say tween.start. Great, let's test this. And I'm going to add a moving platform to our level. I'm going to link it, moving platform. And let's drag it here. And we need to set the export vars, so I'm gonna use the offset and time. I'm gonna put -48 for now, so it's gonna travel up and down. And time, let's leave it at 2. Save, run, and there we have it. The tween is working. You can see the platform is moving up and down, but if I'm trying to interact with it, of course it's not going to work yet. And as you can see, the platform is moving very smoothly now, and this is because we are not following the rule of moving only by integers. When we're going to do that, we're going to lose some of this smoothness, but it's going to be better for us when we try to calculate collisions. So I'm going to close that, and now let's write down the steps of how we are going to move the solid. And the first thing we're going to do is we need to find all the riders. And the rider is just an actor which is exactly 1 pixel above the solid. And the second step is we're going to move the solid by integers only. And this will cause us to lose some of the smoothness, as we talked about, but it will keep our collision checks much more simple. After that, we are going to cycle through all of the actors in the level, and for each and every one, we are going to check for overlap, and if we overlap, we're going to push the actor. Remember that push has priority over carrying, and the last step is to carry all the riders with us. It will be a good idea to put this movement logic in a base script so that every type of solid can reuse it. For that, I'm going to add the solid script and do it in a 3-level hierarchy. The solid script will extend our wall script, and moving platform will extend from solid. Okay, so right click the scripts, and we're gonna add a new script, rename it to solid, create, and let's open it. Delete all that, and now we want to extend from the wall script. That way we get the reference to the hitbox, and it will be a part of the walls group. And first we need the remainder, just like we did in the actor script. We're going to use it to snap to integer values. This time we will start with the y-axis movement, so I'm gonna do func move y, and it accepts the amount. So as we have done before, the first thing I want to do is to add the amount to the remainder y, and then I'm going to round this number and put it inside the move variable. So I'm going to round the remainder.y, and now I'm going to ask if this move is not equal to 0, then we are going to move. But before moving, I want to get all the current riders on this solid. So I'm gonna write var riders equals game dot get all riding actors, and it will accept self, and we are not going to worry about it for now. I'm gonna write it later. Now that I cached the riders, I can move the solid. So I'm gonna do reminder.y minus equals move, and I'm gonna change the global position. I'm gonna add the move to it, so plus equals move. The next step is to cycle on all the actors in the level. Write a for loop, and it's gonna be for actor in game.get all actors. Again, I'm not going to worry about it now, I'm gonna write it soon. The next thing, if you remember, is to check if we have some overlaps with the actors. And if we do, we need to push them. So I'm going to do if hitbox.intersects, and I'm going to do actor.hitbox. We already moved the solid in row 11, so we don't need an offset this time. I'm going to write vector2.0, and now depending on the solid's move direction, we can calculate the distance we need to push the actor. So in case the move is greater than 0, the platform is pushing down on the player. We need to push the player by the overlap amount. The player has to travel from point A to point B, and we do b minus a to get this amount. So it's going to be box.bottom minus player.top. And now for the opposite direction, if the platform is moving up and it bumps into a player, we need to travel this distance. And if we again mark it by A to B, we need to push by beam minus a. So we're gonna get box.top minus player.bottom. Now that we understand the movement, let's write it down. If move is greater than 0, I'm gonna do actor.move y exact, because move is already an integer, and the amount is hitbox.bottom minus the player or actor.hitbox.top. And now for the opposite direction, else the same, we're gonna do actor.move y exact, and this time we're gonna do hitbox.top minus the actor.hitbox.bottom. And for the last step, we need to carry the riders. So we need to check if this actor is riding. So I'm gonna do elif riders.hasActor, and if it is true, we need to carry the rider with us. So I'm gonna do actor.move y exact and pass in the move. Great, so that's it for this function. And now I want to add this side function, the get all riding actors and the get all actors. So let's add these functions to the game. Go ahead and open up the game script and let's add a new function. And we're gonna do func get all riding actors, and it will accept the solid to check for. Now add an array variable. I'm gonna do var riders, and you can define an array by doing colon.array. And we need a way to get all the actors in the current level, so I'm going to do var actors equals get3.get nodes in group, just like we did for the walls. So get nodes in group and add the actors group. Now we need to add the actors to this group, so I'm gonna pick up the actor script, and inside the built-in ready function, I'm gonna do func ready, add to group, and actors. Good. And now cycle these actors. So I'm gonna do for actor in actors. If actor dot is riding, it's a new method. We're gonna write it soon. I'm gonna pass in the solid, and the offset to check for, it's gonna be vector2 down. So we're gonna check 1 pixel down if we are on top of the solid. And if we do, we're gonna do riders.append actor to add it to the result array. And lastly, we're gonna return the riders array. Okay, so now we need to write the isRiding method, and it's very simple. It's just we need to check that if before any movement we are not colliding, but adding this offset, the vector down, we are colliding, then we are truly riding the platform. Okay, so let's write it down. I'm going to open the player script, and we're gonna write go down, let's edit func isRiding, and it accepts the solid and the offset. So we need to check if we're exactly outside the hitbox. So we're gonna do return if you are not colliding with offset 0. So I'm gonna do not hitbox dot intersects solid hitbox, and the first offset is gonna be just vector2 0. We're not colliding. And also we're gonna do hitbox dot intersects solid dot hitbox with the offset. Then we can say we are riding this solid. We're almost done. We just need one last function, and it's going to be the get all actors. We already wrote it basically. We just need to refactor it out. So in the game script, I'm going to write a new function, func get all actors, and it's going to return this row here, and I'm going to copy and paste it. Great, so we got everything in place now. We just need to call the moveY function from within the moving platform. And in order to do that, we can't interpolate the global position directly by the tween. So we need to use another variable, and we're gonna set the global position to follow it. Add a new variable, an onReadyVar, and I'm gonna name it follow. It's gonna be equal to the global position. Now inside the tween call, we're going to change global position to follow. Next, I'm going to connect to the tween step signal. So I'm going to do tween connect, tween step. The object to connect is self, and the method to connect is going to be on tween step. And we're going to add it now. Okay, so let's write this function on tween step. And it accepts few variables, but we're not going to use them anyway, so I'm just gonna write them down. Finally, we are ready to call the move_y function, and we need to call it by the difference between the follow and the global position. So I'm going to write move_y, and it's gonna be follow.y minus global position.y. But that's almost correct. Remember that global position is an integer number. The real difference needs to include the remainder, so I'm gonna add the remainder.y. And now it's correct. And I'm getting an error that the remainder isn't declared, and that's because we haven't extended from solid. So let's do that. I'm going to mark this node to D, and I'm gonna drag the solid script right on top of it. Great, that's it for now. We're gonna save it and run the game and see if it works. Okay, let's jump on this platform. And whoops, something is wrong. Let's see. Okay, so I'm getting an error with this move_y_exact function. And if you recall from the last video, it accepts two arguments. The second argument is a callback. And for when we're carrying a rider, we don't want to use the callback anyway, so I'm gonna pass in null. When we are pushing an actor, I just want to call the squish method, and it's like when the player is squished between two platforms. So for now I'm gonna do funcref. You remember funcref from my other video. And this time I'm gonna pass the actor script as the object, and the method I want to call is the squish method, and copy it to the other push call as well. And let's add this real quick to the player. So func squish. And for now in this video it's getting long, so I'm just gonna print squished. Save it, run the game, and I'm trying to jump on this platform. Whoops, I failed. Okay, I'm trying from below it, on top of it. It's carrying me. It seems like it's interacting well with the player, just like we intended. Let's move this platform down a little and see if the squish method is called when the player is squished. I'm gonna stand here and you can see it's called squished. By now we only did the y-axis movement, and this video is getting too long, so I'm just gonna show you how I did the move X. And it's pretty much the same, but the only difference is the pushing part. And in the moving platform script, don't forget to call move X. Let's quickly add a horizontal platform. I'm gonna link a moving platform, and this time I'm gonna do the offset -48 and drag it here. And let's run the game. And as you can see, now we have a horizontal moving platform. And that covers everything for this video. On the next video, we're going to continue with the moving platforms, and we're going to do jump throughs. As always, I hope you learned and enjoyed this video, and I see you on the next video. Don't forget to like and subscribe. See you. Bye.